Hey, section 10.4, common log notes. Going to start you off with a little word problem here. So, we got a little formula here as far as finding a pH level of a substance. The substance in question is sauerkraut. I don't know about you guys, but I hate sauerkraut. So, we're just using a formula. And I would hope you guys know most formulas is just a matter of plugging in what variables you know, going from there. So, the formula basically says the pH level of, in this case, sauerkraut, is negative log base 10 times H, or of H plus. So H plus is hydrogen concentration, and it tells you right here that the hydrogen concentration of sauerkraut is 2.987 times 10 to the negative fourth power. So we got some good news for you. Your calculator will do log base 10s. The button literally says log. It doesn't say log 10, so it's understood to be. So all I have to do is pick up a calculator, type in the log button. Parentheses are optional, never hurts. And type in this number, scientific notation number, raised to the negative fourth power, and hit enter, and you got it. Now it's going to give you a big funky decimal. Later on in the notes here, it does ask to round to 4 decimals. So we're going to go with 4 decimals on this guy as well, even though the directions doesn't say that. So if you punch this in, it comes out to be 3.524. And then the next digit is a 7, but the 7 is also followed by a 6. So I'm going to round that guy up to 8. And you got it. So pretty straightforward. So just giving you a little introduction here. It's a simple word problem, then the fact that your calculator has a log button. So that makes life easy. So let's try something a little different. So formula is an exponential form. An exponential form means you've got an exponent, and the exponent in this case is x. Well, the goal is to get x by itself. So kind of funky trying to get rid of that 3. And here's how you go about it. If you are allowed to use a calculator, or can you have a calculator do a log for you, I see no log in this problem anywhere. So let's work one in. Hope you would agree with me that if you take the log of one side, as long as you take the log of the other side, perfectly legal move. Okay, now notice I'm leaving the base number off. I'm not going to bother writing 10 because it's understood to be 10. So go back a couple sections in chapter 10, and we learned something called the power rule. And the power rule allows you to yank that exponent out in front. Well, if it's out in front, that becomes x times log of 3. So I no longer have to deal with a variable exponent. Makes life a little bit better. And the goal, of course, is to get x by itself. So I currently have x times log of 3. Well, how do we get rid of a times? We divide. So if I divide both sides by log of 3, sorry about my terrible 3, these two guys cancel. I got x by itself. And you get to pick up a calculator and type in log 11 divided by log 3, which I have already done in my calculator, which I am currently staring at. And I will tell you, to 4 decimals, it is approximately 2.1826. And the 6 is followed by a 5. So I am going to round that 6 up 1 to a 7. So pretty simple, not too bad. Just work a log into the problem. Makes it relatively easy. All right, more of the same here. Exponential form to start with, I have no log. But if I put a log on both sides, that will eventually allow me to pick up a calculator. Excuse me, power rule. Bring that x out in front. X times log of 6. I'm going to get rid of it by dividing. So I'm dividing both sides by log of 6. Calculator time. Pick it up. Type in log 42 divided by log of 6. It should tell you 2.0860. And the O or 0 is followed by a 3. So if this next digit right here is a 3, that means I won't round it. And yeah, you could leave the 0 off at the end there. 2.086 would have been just as good. All right, problem number 3 looks a little tougher. But again, if I work a log in here, I'm going to be able to pull the power rule, and I'm going to be able to pick up a calculator. So the fact it's less than shouldn't change anything. So we want to treat inequality problems more or less like equations more often than not. So we'll solve like normal. So I'm going to pull the power rule again. Essentially, any time that you have an exponent that has a variable in it, the only way or the best way for you to deal with it is to pull that guy out in front. Okay, now the y minus 1, I'm going to put a set of parentheses around that. Never a bad idea for binomial. I have two things. Better safe than sorry. I'm going to put parentheses around that guy. All right, well, if the goal is to get the y on one side, eventually I'm going to make sure that this y and this y are on the same side. So you might be thinking about dividing by y minus 1 there, and you could do that, but then you're creating your fraction with y on the bottom, y on the top. That's kind of messy. So maybe this occurred to you, maybe it didn't. But if I have a set of parentheses, and if that log wasn't there, if it just said 8, you probably would have distributed. So that's what we're going to do. So 8 times, or log of 8 times y would be y log of 8. And then log of 8 times the minus 1 would be minus 1 log of 8. All right, well, I have y's on both sides. That needs fixed. So I am going to move this guy over to the other side with the 3y. It's a positive y log of 8. I know that's more than one item, but still, if a positive something, doesn't matter what the something is, if I want to move it to the other side, I could subtract it. So I already had the log of 5, 3y log of 5 over here. I'm subtracting the y log of 8 over there, so I have my y's on the same side. I'm left with negative 1 log of 8 over here. I'm going to quit writing that 1 because it's confusing me. It looks like an 11 there. All right, ladies and gentlemen, I'm going to say this sentence even though I can't see you, and I'm going to hope you finish it correctly. When in doubt, dramatic pause. Did you say factored out? Because if you did, you're right. GCF, your favorite. There is a y common to both these guys. So why is this a good move? Well, in the previous line, there was a 3y and a y. So if I do the GCF, how many times did I write a y? And get that 1 out of there. So I'm down to 1y, makes it a little bit easier. So guys, sounds crazy, but hey, logs can be done in the calculator. I have y times that mess. So I'm going to divide by that mess. And yes, I'm going to write the word mess. But I am not going to type it in the calculator that way. I got y by itself. So, hey, when you type it into the calculator, you're going to have to type it this way. I've got that negative log of 8. And that's going to be the top of my fraction, but you have to type it into the calculator like this. So divided by the mess. Now I'll actually write it out this time. And even though that's an insanely long mess, hey, it's just a matter of me typing out that big line, long line on the calculator. So I do not have that one ready to go, so I'm going to have to go ahead and do this. So I'm typing the parentheses and all. So parentheses negative log 8. And if you think about it, that's the top of the fraction. So that's why I put parentheses around it, divided by the bottom of the fraction. So the bottom of the fraction is the 3 log of 5 minus the log of 8. Enter. So approximately, I'm going to write this down here. Going 4 decimals again, negative 7.564. The next digit is negative 5647. So 564, sorry, decimal right there, 0.7564. but it was followed by a 7, so this guy should be rounded up. So